Chairman, and thank you to the panel for being here today. Dr. Goward, you talked about Landsat being the Rodney Dangerfield, but I would like to give it maybe a little bit of respect today. Having worked in the forestry industry, I've seen how the imagery can be used. We've had developments in the analytics, being able to look at the images and gain more from the images. In a wintertime photograph, you can tell coniferous trees from deciduous trees, and then now through spectral imagery, you can look at the different signatures of the colors of the leaves and get a species distribution through it. So I know that the analytics have advanced, but how would you say the image resolution and quality of data has changed for Landsat over its 43-year history, and maybe just briefly Landsat 1 versus Landsat 8?
Right. The changes have been subtle. The changes occurred between Landsats 3 and 4, when we went from one type of a sensor, MSS, to thematic mapper, TM. And then with the OLI on Landsat 8, a number of changes occurred, additional bits of data to characterize illumination conditions, narrowing of the bands to increase avoidance of atmospheric contamination. So they may be subtle, but they get critically important information that allows us to more and more reliably evaluate forests, agricultural production, other features that we just simply get better at as we refine our instrumentation.
So we've got a long record of continuous and comparable observations that has allowed users to document changes to the land surface and other features over decades. So what are the advantages and disadvantages of deploying Landsat instruments on other satellites, whether they're government or commercial, instead of recreating the same Landsat satellite as the one vehicle for U.S. moderate resolution land imaging?
I see no reason not to deploy an equivalent instrument on a variety of platforms. The things you have to be careful about are the orbital patterns, whether you're in a sun synchronous or in a solar variant observation condition. But you're certainly not constrained to a single platform.
So you think we can maintain the aspects of the data continuity with different platforms?
No, absolutely, and it's more at the detail level of the instrument characteristics that's critical.
Okay, so the cost of Landsat 8 was about $1 billion, and the administration is now preparing to develop Landsat 9. I think the last I saw, 2023 launch for Landsat 9, which is essentially a clone of Landsat 8. Is there a rush to develop Landsat 9, or does the government have the time to evaluate all options for satisfying these data requirements? And what would you recommend NASA do?
It's an interesting problem. The design life for Landsat 8, from an engineering point of view, is 5 years, so that by the time we get to 2023, we're over 10 years. Now, do we suffer a failure in between time? I don't know. We certainly had problems with Landsat 7 early on, and it could happen again. So are we in a rush? Should be, because we should move that timeline for the next launch to an earlier date, if at all possible.
So how many Landsats are we getting imagery from now? Are there still 2 collected?
Still 2.
And what, those are 8 and
7.
Okay.
And 7, of course, has a partially functioning mirror system.
Okay. And with that, I'll yield back, Mr. Chairman.